Hello everyone. Today we are going to be discussing some questions from topic 6 in our homework. I'm going to be looking at the items of normal distribution and income tax. Alrighty, let's get started. I'm going to start with a little discussion about the normal distribution. The normal distribution is also called the bell curve or Gaussian distribution. Normal distribution is bell-shaped and symmetric about the vertical line. That vertical line is the line that runs through the mean, median, and mode as they are all equal and all located at the center of this distribution. Notice it's symmetric as we get to the normal distribution. Let's open this up just a little bit. What I mean is this. Take a look at the first graph, and you notice that we have a histogram here. We have a histogram that has the widths of the bins somewhat wider because we have a group of 100. All right, next we're increasing our n, the value of n, our sample size. Therefore, our bin widths are more narrow. And again, in this lower one here, the bin widths are more narrow, and we are approximating the normal distribution. And here you can see we've increased n out towards infinity, and our normal distribution is smooth. You can see the highest point of our graph is where the mean is, right in the center. Remember, that's the mean, median, mode, right in the center of our distribution. So as we continue, we're going to talk about percentiles. Remember, right in the center is the mean, median, and mode if it is a normal distribution. If this is not a normal distribution, obviously they're not all in the same place. But with normal distributions, this value right here is the value right in the center of our distribution. It's called the mean, median, or mode. You can see from our percentiles, 25% is in the first quartile. That's right here, 25% in the first quartile. All right, 25% in the second quartile. That means 50%, right? 50% here to the left, 50%. All right, 25% in the third quartile, 25% in the fourth quartile, meaning 50% above the mean. All right, 50% above the mean, 50% below the mean. Therefore, right, if we take the whole percentage of this curve or distribution, we have 100%. Now, each one of these, as it's divided up here into 25%, you can call those quartiles. The first quartile is 25 percentile, 25th percentile. The second quartile, 50th percentile. The third quartile is 75th percentile. And the fourth quartile would be the whole thing, which would be 100%. Okay, so keep these in mind as we go. Everything is symmetric about the mean or the center of this distribution. All right, the first question I'm going to look at today is a question that is very similar to question number 7 in your homework, topic 6. Let's go through this together. It says the weight in pounds of 20 preschool children are, and given to us here are the weights of the children. We want to find the 25th and the 60th percentile for these weights. To find the position of that percentile, we're going to use n times p divided by 100. All right, so step one is to sort the data. You can do this by whatever means you want to. We're going to sort it from least to greatest. You can see I have my list of 27. I called it L1. In Desmos, I organized it using this formula, and now I have it organized. Let's click here. I have it organized from the least 21 to the greatest 50. Okay, so that's my whole data set organized from least to greatest. Now I'm going to use the position function given to us as n times p divided by 100. So in my example here, you can see that I have n is 20. Here's n. Here's p's 25, and the value that I get returned to me here is 5, okay? That means that is the 5th position. So if I count down here on my chart that I organized from least to greatest, 1, 2, 3, 4, 5. There it is, right? The 5th one right here. It tells me that 31 is the value that's in the 5th percentile. Since this number 5 is an integer, I need to find the mean of the 5th and the 6th positions. Okay, that's these two values right here. All right, so let's scroll down just a little bit on my graph. Scroll down here just a bit on my calculator. And you can see I added 31 plus 32, right? That's because 31 is the 5th right here. 31 is the 5th. 32 is the 6th position. Therefore, 31 plus 32 divided by 2 is 31.5. Okay, notice with me, 31.5 is between those two values. So I'm right here, right? 31.5. All right, what did it tell me? It told me this is the 25th percentile, meaning what? Meaning 25% of the data lies below 31.5, okay? That's exactly what it means. So we have found the answer to that question. The 25th percentile is 31.5, meaning once again, 25% of the data lies below that value. All right, very good. Let's clear this one out. All right, next, it wants me to find the 60th percentile. Let's scroll down on my Desmos calculator, 60 times 25. Once again, remember, I'm using this formula, n times p divided by 100. 60 is n, 25 is p. Oh, that's not correct, is it? Let's try this again right here. This is 20, this is n, times 60. Whoops. I'll get this right here, give me just a second. Times 60 divided by 100 is 12, okay? That's the 12th position. Okay, so let's get rid of this value right here. We need to change these values because I had an incorrect calculation. All right, let's go back up here and look for the 12th position. Everybody with me, okay? The 12th one. Okay, let's count down here together. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right there. That's the 12th position, is 41, okay? So 41 is the 12th position. That is an integer, right, everybody? What's an integer? Scroll back up here. 12 right here. 12 is an integer. Therefore, I need to find the 12th position and the 13th position. What were those values once again? That is 41 and 42. That's the 12th is 41. 42 is the 13th. So scroll down here. Let's clear our data up here. I mean, our graph. So in here, I'm going to put 41 plus 42 plus, right? That's the 12th and the 13th position. It comes out to be 41.5. So scroll back up here, and what does that mean? We want to always understand what it means. All right, right here, 41.5 is our 60th percentile. Okay, once again, what does that mean? It means that 60% of the data lies below this value, right? Up through here. 60% of the data lies below 41.5, okay? And that is the answer to our question. We have found both the 25th and the 60th percentiles. And that is the answer. And to this question, it is completed. Once again, step one, we found n times p divided by 100. It came out to be 5. It's an integer, so we look for the 5th and the 6th values, add them together and divide by 2, and it came out to be 31.5. 31.5 is the answer to my question for the 25th percentile. Second part, I wanted to find the 60th percentile. That is n 20 times 60 divided by 100 is 12, which means I need to look for the value that's in the 12th and the 13th position, which happen to be 41 and 42. Divide them by 2. When I add them together, divide by 2, and I get 41.5, which is the 60th percentile. And that question is completed. All right, continuing on. I want to now talk with you about this rule for the standard deviation and the 68, 95, 99.7 rule. Okay, it says approximately 68% of the data, remember this isn't a normal distribution, approximately 68% of the data falls within one standard deviation of the mean in both directions. All right, so notice with me here, I took the 68. Let's change the color up a little bit this time, shall we? There we go. All right, so I took the 68 and I divided it by 2, and that gives me 34. What does that mean? It means that 34% of the data lies below the mean by one standard deviation, and 34% of the data lies above the mean and below one standard deviation. Obviously, the two of those add up together to be 34, and 34 is 68. Next, it says 95% of the data falls within 2 standard deviations, okay, above and below the mean. So I took 95 divided by 68, divided that by 2, and that tells me that 13.5% is in each one of the percentages, each one of the regions right here. So this is 13.5 here, and this is 13.5 here. All right. Next, it says 99.7% of the data lies within 3 standard deviations. So I took 99 right here, 99.7 divided by 95, minus 95 divided by 2 gives me 2.35. All right. So that is 2.35% of the data is between -3 and -2 standard deviations, and 2.35% of the data is between 2 and 3 standard deviations. Okay, lastly, remember we discussed a moment ago that 100% of the data must be beneath this normal curve, normal distribution. All right, that being said, what lies beyond the plus or minus 3? That's above 3 and below -3. That is 100 minus 99.7 divided by 2 is 0.15, telling me that 0.15% of the data lies above 3 standard deviations and 0.15% of the data lies below negative 3 standard deviations. Okay, these values will help you answer any question that pertains to this rule. Okay, we're going to use this here in the next question to help us answer some questions. All right, let's clear this writing out and let's see what comes next. All right, it says use the empirical rule to identify values and percentages of a normal distribution. The height of an 8th grader is modeled using the normal distribution. The mean is 60.8, the standard deviation is 2.1. In the figure, V is the number along the axis and is under the highest part of the curve. U and V are numbers along the axis and are each the same distance from V. Use the empirical rule to choose the best value for the percentages of the area under the curve that is shaded and find the values of U, V, and W. Okay, let's see what we're working with. This is question number 11. Let's pull that up in our calculator. Question number 11. All right. First of all, remember that the mean is the number that is in the center of our graph at the highest point. That's what our previous chart told us. All right, therefore, let's draw a straight line here. We're just going to approximate this, right? It said it was at V, so right up here through the center, this is our mean, okay? That's the mean, and we're told right here that the mean is 60.8. So remember, the mean is V, it's 60.8, and it is the 50th percentile, right? 50% of the data lies below the mean. That's what we were told. All right, good. So we've answered that one question. Now, U and V are equal distance from the mean along the x-axis, all right? You can see they're between, the U is between 58 and 60. So if I go take a look at my calculator and I see if I take 60.8 minus 2.1, that is 1 standard deviation, I get 58.7 right here. 58.7 is approximately what the value of U is right there. All right. So U is 58.7. Now, somebody's going to say, well, what percentile is that? Well, it's 1 standard deviation below the mean. Remember we said just a moment ago that the percentage between -1 standard deviation and the mean is 34%. That's what we said. So what's the percentage that lies below that? That is 50. Let's just do it in our calculator right here. All right, that is 50 minus 34, right? 50 minus 34 lies below that. So that is the 16th percentile. All right, that is the 16th percentile. That's a 16 there, okay? So 16th percentile, in other words, 16% of the data lies below U, which is 58.7, okay? Next, for W. W is 1 standard deviation above the mean. How do I know that? Because it's equal distance from the mean as above as U is below. So if I take 60.8 plus 2.1, I get 62.9. So that's the value of W, 62.9. All right, and what's the percentile? Remember again, this is 34%. Therefore, let's just put this in our calculator once again. 50 plus 34 is 84% or 84th percentile, okay? All right, so this is 62.9 is the 84th percentile, meaning that 84% of the data lies below W, which is 62.9. All right, very good, everybody. Appreciate you guys working with me here today. All right, let's keep going. All right, that was question number 11 from our homework. All right, question number 12. Let's grab our calculator. All right, question number 12. It says on a nationwide test taken by high school students, the mean was 46 and the standard deviation was 11. All right, the scores were normally distributed with complete the following statements. Approximately 95% of the students scored between what and what. Now remember with me, on our previous chart, 95% of the data, let's go back and look, okay? Let's just scroll back up here. It won't take but a sec. All right, 95% of the data here to here is plus or minus 2 standard deviations, okay? So we want to know approximately 95% of students scored between what two values, okay? Let's go with it. 46 is the mean. 46 minus 1 standard deviation is 35. 46 minus 2 times the standard deviation is 24. That is my answer, right? That's 2 standard deviations below the mean, right, everybody? All right, just draw this out here. Here's my mean, 46. 1 standard deviation below the mean is 35. 2 standard deviations below the mean is 24. All right, let's just keep going while we're at it. 3 standard deviations below the mean is 13. 1 standard deviation above the mean is 57. That's right here. 46 plus 11 is 57. 2 standard deviations above the mean is 68. 3 standard deviations above the mean, that is 46 plus 3 times 11 is 79. All right, now remember, we said on our previous chart that 95% of the students are going to be between here and here. This is 95%. All right, so we've answered the first question. The question was approximately 95% of the students scored between what? Between 24 and 68. That's the answer to that question. All right, let's change the color up here so we don't get ourselves confused. Let's go to the next one. Approximately what percent of the students scored between 13 and 79? Notice my 13 is right here. Let's just do it below so I don't confuse. Okay, 13 to 79. What percent was that from our previous chart we looked at? It is 99.7. All right, what does that tell us? It tells us that in this high school exam, 99.7% of the students got between 13 and 79, where the average was 46. Okay, and you can see I've done all the simple calculations. All I'm doing is adding or subtracting standard deviations and following the chart we had before, the 68, 95, 99.7 rule. All right, super. That was number 12 from our homework. We're doing great. Let's keep going. All right, number 13 in our homework. Let's pull up our calculator and work right along with us, all right? It says the standard normal is graphed below. Shade the region under the standard normal curve to the left of z equals 2. Now, remember, let's just remind ourselves, we're talking about z-scores. Okay, so remind ourselves this, that z is equal to x, which is our data value, minus the mean, x bar, divided by our standard deviation, or sigma here, okay? So x minus x bar divided by sigma, or we can also use s there as well, right? Sometimes that's used for the standard deviation. All right. And z tells us how many standard deviations we are above or below the mean. That's what it tells us. So z equals 2 says we are 2 standard deviations above the mean. Everybody with me? If we're going to shade this in, it's positive 2, so it's to the right. It's right here, right? It's right there. Everything here is shaded in, right? This is all going to be shaded in. All right. Now, we're looking for, well, that's the answer to part A, and that is we are 2 standard deviations above the mean. Shade the region. Since it's positive, it's to the left. Obviously, if it was negative, it'd be to the left, because shading with a normal distribution is always to the left. That's what a z-score gives us, the area to the left. Okay, let's clear this out. It says, use this table. This isn't Alex in your homework. You can just follow the link, right? To find the area under the standard normal curve to the left of z equals 2. We could do it with our table, or we can do it with our calculator, okay? We'll just go ahead and do it with a table. Let's go ahead and pull it up. I'm going to pull it up with you guys. This is the z table, okay? And I want to find the z-score of 2. In my table, the z-score of 2 is right here. You can see it is 0.9772. You can see the shading up there, that the z-score always gives us the percentile to the left. In other words, this table reads the z-score and gives you the area to the left of that z-score. And you can see it's 0.9772. Okay, so 0.9772 minus 0 is 0.9772. Okay, so the area that we are looking for is 0.9772, which tells us what, once again? That tells us that 97.72% of the data lies below that z equals 2. That's what it says, okay? Good, super good, everybody. All right, let's keep going. Next, we're going to look at example for number 14 in your homework. All right, number 14. Let's pull that up in our calculator here in Desmos. All right, so we're going to use that same table again. It says find the area under the standard deviation to the right of z equals negative 1.47, okay? Just remember, let's draw ourselves a picture. We got to use the same thing, same idea over and over again, okay? So here's my z-score, my normal distribution. All right. Here's my center. Remember, this is my mean right here in the middle. And this is where I have a z-score of 0. Z equals 0 is the mean. And it says I am negative 1.47. So let's go about right here. Z equals negative 1.47. All right, and I want to find the area that is to the right. Now, everybody, stay with me here, okay? When I find the z-score value, it's going to give me this shaded region here. That's what it's going to give me. But that's not what I want to know. What I want to know is what is the area to the, see right here, it says to the right, okay? To the right. I want to know this area, okay? So if I'm going to find this area, I'm going to have to find 100% or 1 minus this area I shaded in here, okay? I look this value up in the table, negative 1.47. I'll go there with you right now so you can see, okay, what I'm looking at. All right, so negative 1.47. All right, this is positive. I need negative. Negative, here we are, 1.4. Just go across till we get to 7. There it is right there. 0.0708. 0.0708 is the area, okay? So to find the answer, I need to take 100 or 1 minus 0.0708, which is 0.9292. All right, and it wants me to give my answer with 4 decimal places. Okay, so the answer is 0.9292. That's the area to the right of that z-score of negative 1.47. Now, just a moment, think about this. Since the z-score is negative, it must be to the left. Therefore, if I want to find the area to the right, it has to be more than 50% because 50% is half, right? I think that makes pretty good sense. All right, let's go for the second one. All right, the second one says, find the area under the standard normal curve between z equals negative 2.28 and z equals negative 0.46. Let's draw a picture for ourselves again, okay? Hey, you know what? I think I can do better than that. You guys think so? Yeah, I'm pretty sure, but I need some help. All right, so here's a straight line this time. Hey, that works out a little better, right? All right, let's do it. So draw my picture. All right, here's my mean. Remember, this is z equals 0. All right, negative 2.28 is back here somewhere. So negative 2.28 is here, and negative 0.46 is about right there. All right, so I'm going to do a little bit of erasing here. All right, I'm going to get rid of this. We all know that already. Okay, so this little guy right here is z equals negative 0.46 and z equals negative 2.28. I need to find the area between those two, okay? So I got to do a little bit of work here. This is the area I'm looking at right here, okay? So I need to find the value of z point negative 0.46 minus z equals negative 2.28. Once again, what am I looking for? I want to find z of negative 0.46 minus z negative 2.28, okay? Those values, all right? Let's go look them up in the table. You can see I already have them right there listed for you, right? 3.228, negative 0.113. Those are the two values. Let's go find them, okay? I'm going to erase this picture so that it doesn't show up on my table when I go to look at it. All right, let's go look at the table. All right, once again, negative 2.28. Here is negative 2, right here. Negative 2.28. I'm coming across, right there it is. You can see it's 0.0113, okay? 0.0113 is negative 2.28, and negative 0.46 is right here. Let's go across. Negative 0.46, where are we? Here we are, 0.3228, all right? So 0.3228 and 0.0113. 3.228, 0.113. The answer is 3.115. So once again, the area in between those two is 31.15%. That's what the answer is, okay? So once again, my answer here for this z-score is 0.9292. And this answer is 0.3115. Note to self here, okay? Whenever you want to find an area between two z-scores, you always take the greater value, in other words, the z-score to the right, that value, minus the z-score to the left, okay? You do that and you will not go wrong here. Very good. All right, let's clear this out and keep going. All right, number 15. Let's pull this up in our calculator in Desmos. In case you guys are wondering, I only use two calculators in Math 144, either this calculator Desmos or Excel, okay? You can save them both and reuse them. Look, okay, look everybody. Click right here on these three bars where I'm going every time. You can see all the things that I've saved in my calculator. Look, I have all these functions. I have just about every function you could want, okay? You can save them, come back and use them again. Let's do it. Finding a probability given a normal distribution. This is similar to homework question number 15, topic 6. A certain manufacturer makes a 400-watt light bulb. Assume that these bulbs have a lifetime that are normally distributed with a mean of 590. Okay, so the mean is 590. All right, the mean is 590, and it tells me that my standard deviation is 75. Remember what I said a moment ago. Z is equal to X minus the X is the data value minus the mean divided by the standard deviation, okay? Use the table or the Alex calculator to find the percentage of light bulbs with a lifetime with lifetimes longer than 434 hours. Okay, so that tells me that X equals 434. All right, now I'm going to put this into my calculator, and right here I did, right there I did. X 434 minus the mean 590 divided by 75, the standard deviation gives me negative 2.08. So I now know that Z equals negative 2.08. Okay, everybody, just to remember, okay, draw yourself a little picture. Just remember. All right, this is Z equals 0, and here is Z equals negative 2.08. All right, I want to find the area. What's it say? Lifetimes longer than 434. I want to find this area right here, all of this. That's what I want to find. Therefore, I need to find 100% minus the value that I look up in the table. Everybody with me, okay? 100% minus the value that I look up in the table. So let's jot this down over here just so we don't forget it. Z equals negative 2.08. I know it's in the calculator, but I'm going to shut the calculator down here for a moment, right? And go to the next slide. So let's erase this, right? Let's erase this so that it doesn't interfere with our table when we go there. And what are we looking up? We're looking up a value of negative 2.08. All right, negative 2 point, here's negative 2. Let's go all the way across. Negative 2.08 is right there, the last one, 0.0188, 0.0188. Just jot this down, okay? So we don't forget it. 0.0188. Let's go back to our calculator. 1 minus 0.0188 is 98. Why'd I take the 1 minus? Remember, what I did was I want to find the area to the right. I was given the area to the left. So I subtract 1 minus that area, and it's 0.9812. All right, that tells me right away that right here, the percentage of light bulbs with a lifetime longer than 434, that percentage is, it says give your answer with 2 decimal places right here. So that is 98.12% is the answer I'm looking for, okay? Obviously, the 434 is way below the mean, right? And 50% of the light bulbs have a value greater than 590 lifetime. Therefore, 98.12% have a lifetime greater than 434 hours. All right, very good. Thank you, everybody. All right, let's keep going. We have one topic left to talk about in this little video. We're going to talk about calculating income tax using a tax bracket table. This is like question number 19 in your homework. All right, so notice first of all that we have 4 categories, right, everybody? 4 categories. So when you're using the tax table, the first thing you want to do is to look up the 4 categories. All right, so notice right here, first category, single, married, joint filing jointly, married filing separately, or head of household. All right, so each one of these columns shows you the category that the person falls into as far as household goes. Secondly, I look down the rows and it tells me what percentage and what interval I'm working with, okay? So if I'm looking down here, you can see this is an income that is right here, less than 12,750, less than 8925, less than 17,850. And if that's the case, a person would pay 10% of their income. And as I increase the income, I increase the tax bracket as I go to pay more income tax, okay? That's the whole idea here. All right, so let's look at our example. What question do we have? All right, it says Louis V. Louis V, right? Louis V, King of France, had a filing tax status of head of household and a taxable income of $124,769 in the year 2013. How much did he owe for federal income tax? It says, do not round any intermediate computations. Give your last answer to the nearest dollar. So let's go grab our calculator. All right, here we are. All right, notice I set up a little table here, everybody, for income. That's I. And I put in the 124,769, okay? And here is the calculation I'm using. Notice it begins with 10%. Let's pull up our table back here again, okay? Let's pull this back up. All right. Louis V is head of household. So we are in this column right here, right? Looking at this head of household. How much did he earn? He earned $124,796. That means he's in this category. Why? Because he earned less than 125,450. He earned 124, which is just a little below this, so he's in this category, which means I need to use these 3 rows for my tax calculations, okay? These 3 rows. So notice I started right here, 10% of this amount from 12,250 down to 0. That's here in my calculator, 10% of that amount plus 15% of the amount between 48,006 and 12,750 plus 15% of that amount plus, there's my 25%, 25% of the amount above 48,600. It's not the 125. He didn't earn 125. He earned 124. So that is I, notice here I put I, which is 124 right there. 124 minus 486 means this person, Louis, owes $25,701.50. Okay, that's what he owes. I'm going to round that off to 2 decimal places. Right? $25,701.50 is what Louis owes. Obviously, as the income is reduced, he would pay less and less income tax, right? If Louis, watch the slider here, okay, with me? As Louis's income goes down, he pays less income tax, right? Watch. Scrolling down. You can see it goes down, down, down. Once I get below 48.6, I'm going to drop off that 25%, right, as I'm going down. I'm almost there, right? Almost there, right? There's 48,000. So 48,000, if I put that in right here, 48,000 minus 48.6 would be $600 times 25% plus this amount back here. Okay, so as the income goes down in this head of household category, my value is going to keep changing. Okay, if I were to have a different income category, I would have to change it up just slightly. Okay, but just to reiterate, okay, everybody, just to reiterate here, let's take our income back to where it was, right? 124,796. Let's clear this out, this writing. The answer to the question is, how much did he owe right here? How much did he owe for federal income tax? The answer is $25,701.50. That's head of household. Now, you guys could do this very easily for the other categories if you wanted to, okay? Watch. If I do this, I'm just going to choose another one. Say single. Head of household means you have people who you are taking care of, dependents. Otherwise, you would be single, right? If I were single and I made 124,796, notice I'd have to go up to this category right here. I'm now in the single column. This only goes up 25%, only goes up to 87. If I'm single, I go up to 183,250, which takes in that value of the income of 124,796. So once again, this line right here that I just completed, this is for married head of household. That's the answer to the question. If this individual were single, watch what I'm going to do. Okay, I'm going to copy this. This makes some easy work for me here, right? Copy this and change this up just slightly, right, everybody? I just have to change a few numbers here. So let's scroll back down through here. 10% times what? If this person is single, it's 8925. So right here, 8925, 89, all right? All right, plus 15%, and I have to change this to what? What's the for the single? It is 36,250. 36,250 minus 89.25. All right, plus 25% times, got to change this up. This is 87,850 minus 36,250. All right, now I need to keep going because this person earned more than 87,500. I'm using the same income as before, okay? Plus 0.28 times I minus 87,850. And there is your value, okay? So everybody, please notice with me. This is the same income, just a different category of household, all right? So for a head of household, the person pays 25,750. A single individual with that same income tax pay a same level of income rather pays $28,236.13. All right. So you could use this exact same setup in your Desmos calculator to answer all these questions, or you could set it up in Excel just as easily, make it work very quickly for you guys. All right. I appreciate your time and attention here today. Take care, everybody. Hope topic 6 goes great for you. Talk to you later. Bye-bye.